Okay, looking at one more where we've got an absolute value greater than a number, but before we can make our trade, remember that we have to get the absolute value expression by itself on one side of the inequality. So that means we've got to get rid of that 4. We're going to divide each side of the inequality by 4, which is going to give us, on the left, or right up here, we're going to get absolute value of 3x minus 21 is greater than 15. Now we can make our trade. So we've got an absolute value that's greater than a number, so this is going to become an OR compound inequality. So we set whatever's inside the absolute value bars greater than the number or less than the opposite of the number, so negative 15, and just solve both of those. So we'll add 21 to both sides and get 3x is greater than, what, 36? Divide each side by 3, and we get x is greater than 12. Or on the other side, the other inequality, if we add 21 both sides, we get 3x is less than 6. Dividing by 3, x is less than 2. So those are our two solutions. This is an OR inequality, so we replace the word OR with the OR symbol, the mathematical OR symbol. So we get something that looks like this. Okay. Okay, same kind of thing going on. Let me roll this down. So now this time we've got to subtract 9 from both sides to get the absolute value by itself. If we do that, we're going to get on the left side the absolute value of 3x plus 30 is less than or equal to, what do we get there, 57. And then I can now make my trade. I've got an absolute value expression that's less than or equal to a number, so this is going to become a compound and inequality. So whatever's inside the absolute value bars goes in the middle. And that's going to be greater than or equal to negative 57 and less than or equal to positive 57. Now all we've got to do is isolate the x. First I've got to subtract 30 from all parts, which gives me 3x in the middle, negative 87 on the left, and what do we get here, 27 on the right. Last step is divide everything by 3. And so that's going to give me negative 29x and 9. So that's my answer. Oops. Okay, this is a little tricky. So now we've got an absolute value that's greater than or equal to a negative number. Well, an absolute value can only output 0 or a positive number. And so therefore, that answer is always going to be true. So we don't even have to do anything. We know that this is going to be true for all values of x, so x is therefore unrestricted. Remember, our way of writing that is to say all values of x, we would just say x is greater than negative infinity and less than positive infinity. And that ought to be pretty familiar from all the stuff we did in Module 1. So x is greater than negative infinity, less than positive infinity. Okay. Okay, so this time we got a little bit of stuff to do here to get this ready to make the trade. I've got to do a couple things to get the absolute value by itself. So remember, when I reverse order of operations, the first thing that I have to do is undo addition or subtraction. So we'll subtract 9 from both sides. When I do that, I get on one side, I'm going to get negative 2 times the absolute value of negative 28x minus 252. And on the other side, we got greater than, negative 952. Okay, next step would be to divide each side through by negative 2 to get the absolute value by itself. But remember, whenever we divide an absolute value, or an inequality by a negative, or if we multiply an inequality by a negative, it means we have to flip the direction of the inequality sign. So then we end up with the absolute value of negative 28x minus 252 on one side. On the other side, negative divided by negative is positive, and half of 952 is going to be 476. And that means we have to flip the direction of the inequality sign. Okay? So now we can make our trade. Now we've got an absolute value less than a number. So when it's less than a number, remember, a way to remember this is that the inequality points at the strange kind of compound inequality, the one that doesn't use an or. And so that means this is the one that becomes a compound inequality with no or in it. So whatever's inside the absolute value bars goes in the middle. On one side, on the right side, so the upper limit is going to be positive 476, and on the left side, the lower limit is negative 476, and now we just have to get the x by itself. So to do that, we're going to first add 252 to both sides. And that's going to give us negative 28x in the middle. On the right side, what are we going to get? That's going to give us it's going to give us 728. And on the left side, we're going to get negative 224. So now all we've got to do is divide each side, last step, by negative 28. Remember, dividing by a negative means that we've got to flip the directions of the inequalities. And we end up getting x in the middle. On the left side, negative divided by negative is positive. And what's that going to give us? 8. Oh, sorry, not 8. It's going to give us... Yeah, it's going to give us 8, isn't it? think that's right. Pretty sure. Maybe we should check it. I'm pretty sure it's 8. That's right. It is. Yep, it is. So, and then the other side, 728 divided by 28. Oh, that's not going to go either. I better check that one. I'm not going to do that in my head. That gives us, 26. It does go evenly. Okay, so on the other side, we're going to get, flip the direction of the inequality. We get negative 26. So then we have to flip this whole thing around, right? Because then we need when we write a compound inequality, we have to write the lesser value on the left and the greater value on the right. So it's going to end up being x is greater than negative 26 and less than 8. That's our answer. So let's put that in. What was that again? I forgot what that was. Less than negative 26, greater than 8. There we go. Okay. Okay, we've got a greater than or equal to 1. We have to divide both sides by negative 12. So dividing by a negative means we have to flip the inequality, which means we get the answer then, or not the answer, we get the expression absolute value of negative 4x plus 12 is, got to flip that, so it's less than or equal to, and then 0 divided by anything other than 0 is 0. So what happens with this? Well, now we've got an inequality where the absolute value is less than a number, so that means that what's inside the absolute value bars goes in the middle, and it's greater than or equal to negative 0 and less than or equal to positive 0. Well, negative 0 is just 0. 0 doesn't have a sign, and so in other words, if something is greater than or equal to 0 and less than or equal to 0, the only way that that can happen is if it is equal to 0. And so now to solve, this just becomes an equation, and to solve this I would just subtract 12 from both sides and get negative 4x equals negative 12. Dividing by negative 4 gives us x equals positive 3. Okay. Okay, I'll add one more now, and then I'll add the rest of them a little bit later. So there'll be a part 3 coming up soon. All right, so on this one, we just have to, before we can make our trade, we have to subtract 2 from both sides, which gives us on the left the absolute value of negative 4x minus 20 is less than 16. So I have an absolute value expression less than a number. So that tells me that I'm going to write a compound inequality. That's my trade. Absolute value for non-absolute value. Negative 4x minus 20 then is greater than negative 16 and less than positive 16. So let's go ahead and just add 20 to all parts, which gives me negative 4x in the middle, positive 4 on the left, positive 36 on the right. I'm going to divide everything through by negative 4. So dividing by a negative means I flip the direction of the inequalities. In the middle, I get x. On the right side, I get -1. And on the left side, 36 over -4 is -9. So once again, I've got to reverse this whole thing. I've got to put the 9 on the -9 on the left and the -1 on the right, because we have to go from lesser to greater. X is in the middle, and so that reverses the direction of the inequalities again. So that's our answer. Okay, and I will do the last 4 of them soon, and that'll be part 3 of this.